Now I kindly join in welcoming Dr. Ajeet Jain sir onto the stage for presenting on AI and ML techniques and applications. Sir will be sharing insights on paper number 11 titled Cognitive Horses of Deep Learning, Regularization and Optimization. Now let's invite Ajeet Jain sir on the stage.
Good morning. Namaste. Vanakkam. We are doing a natural language processing and we live in two states of our country. One is called Bharat, where people speak Hindi. Another is called as white collar wala, where people speak English. So we live in two states of our affair. One is Bharat, another is India. And since Sanskrit was the very old language, I have SC for 10 data where 10 classifications are there. I have 1 million data set available and you have to classify the images into so if it is a bird, you have to say bird only. You can't say anything else. So you have a lot of images available. So image classification is one of the wonderful job of the deep neural network, and we can classify the images into this, and you can see the images are corresponding to airplane, automobile, bird, cat, deer, dog, frog, horse, sheep, and then. Now my optimizer has to only learn about the 10 classes right now. Now imagine if you have different 1,000 number of classes, your optimizer is going to fail. And if a person is detected with a malignant cancer and the person doesn't have a cancer, he will be dying automatically. So optimizer's job is very, very profound. It has to correctly predict. One mistake in 1 million is probably acceptable, but one mistake in 1,000 is not acceptable. So that is the job of the optimizer. So selection of your optimizer is to be done very cautiously. And I have a lot of results available on NADM, ADAM, everything. I have tested most of the optimizers and you can see the accuracy curve. Some of the optimizers are performing very good. Some of them don't even respond to the change of them because your intricacies of the optimizers are different. So whenever you are trying to use an optimizer, you have to look at the mathematics inside. Then it will be able to tell you, is there a linear or a non-linear or a second order derivative optimizer. Okay, so I have tested a lot of results I have, and this is I have a input. I want to generate a fake smile of the Mona Lisa. Fake smile, not a real smile. Every one of us know. So you go to corporate hospital, the front people do the Mona Lisa job only to take out the money from our pocket. Fine. So I have a beautiful one. So I have a encoder and a decoder, and I generate a fake smile, and the Albert Einstein is going to come and teach in my class. That is the job of my. Fine. So that is what we do in our parallel programming and our machine learning algorithm. So we can generate that kind of pictures and do it. And if you have, this is another beautiful applications of my deep neural network. I have a historical papers written by King Akbar. Answer is wrong because King Akbar never knew how to read and write. He never knew how to read and write. So question itself is wrong. Okay, so I have a noisy data. Can I make a noisy data as an input? Can I filter that output? Entire our museum can be digitized with because earlier the paper quality was not very good. People used to write on the paper and the quality of the paper we know. Now the quality is very good and the age of the paper was not very good, but we have to digitize every information. So can I get a paper which is having a dirtiness? Can I get it cleanliness? Yes, we can do it in the deep neural network and I have done that. And very popular for film industry, generating a person who is not existing in the world. So we have generating adversarial network and we can create images of the people who are not exactly available in the world, but they will be behaving exactly like a human. So a lot of animations are required and GAN is there for this, and optimizer has to perform very well on this. So you can see that results are there and you can see the faces where people are assisting but still available. Like Bhima, Lord Hanumana in a smaller form. Can I generate it? Very simple and we will be able to do it. Now look at the optimizer performance I am showing you. I have on the left hand side, a dog is running in the water. Can an optimizer predict it? As a human, I'll be able to, but an optimizer probably can be. So it is showing you if I use a NADAM optimizer, it's showing you this is a image to text description. So a black dog is running blah, 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 whereas only, so some of the optimizer will give you a good result, some of the optimizer will not give you understanding at all. My answer is never believe anybody on the internet. First answer we have to learn whenever we are doing research. Everybody claims that I am the great. Prove it. And the proven fact is nobody is great. It is an ad hoc learning. People learn and claim that this is the work. You have to counteract that work. You also become great. Okay, that is what we do in our machine learning. So you can see that I have a lot of captions running on this, and we can see that some of the optimizers perform very well. And I am coming to the end of my talk now. I have comparison of all optimizers I have done. Okay, I have done a lot of research work on that. And concluding, number one, begin with a simple data set. Don't try to jump on the conclusion. Simple things make the life very simple, and simplicity makes the life very easier. So this is the first one. Second thing, do a empirical comparison of a optimizer. So we can do a empirical comparison of the optimizer, which optimizer is performing very good, which is not able to perform. So even a good person having a intelligence will be failure. Why? Because he has not generalized his model. A normal person can win the race, true. A good optimizer can also lose the race. So this is what a conclusion I have drawn. And I have add-on RMS prop, so many optimizers are there, and then we have regularization technique available, so many regularization technique we do it. And last is Gracia, thank you. Thank you so much for patience listening and giving a chance to talk to you. Thank you so much.
Wonderful, excellent summarization of the core themes or core objectives and aims of machine learning and deep learning. I have only one comment to make. In any optimizer, the data quality and the data range and the nature of the data distribution, probability distribution, will decide the functionality of the optimizer.
Yeah. And we as sir said, we have either use a Gaussian distribution or we use a binomial distribution to train the network. Normally we train the network with a Gaussian distribution because of the probability close to 1. But sometimes it may not work, sometimes you have to go to with the binomial distribution also. So it depends upon the type of the input, and as sir said, we can have a comparison based upon the, so most of my work is basically empirical. Theory is there, but is it able to perform or not?
So what's the point I am trying to make is, if you have assumed Gaussian distribution, let us say.
Yeah.
Supposing the adversary, that is the hacker, will take the normal distribution or Poisson distribution and feed the data, the algorithm will fail. That is called adversarial attack.
Adversarial attack. That is called adversarial attack. What sir said is correct. So, anyone has any other question? Okay, so once again I tell my guide also, he is here, Dr. Sharma, he was guiding me throughout my work, and I am thankful to our professor and all of our good friends here to give me a chance to speak. Thank you so much.